Hey, good evening. Hi, Jen. Welcome to
Hi.
Environmental Coffee House. It is Sandy Schoelles and Jennifer Hynes tonight. And welcome back, Jennifer. I missed you on Fridays. I missed you
Oh,
for the
I
last two
missed you
Fridays.
too.
Yeah. Well, so what's been going on before we start? Because we do have a packed show, guys. And
Oh,
actually,
we
it's
do.
Arctic and permafrost night. So everybody's saying hi. Rich, Diana, Cindy Seeley, Grateful Dan, Kim, Di, everybody. Climate Marcher, hi, Climate Marcher. Thank you for today. I saw him on Tom Hartman's chat.
Oh,
Yeah. So tell us what's going on, hon.
well, I haven't seen my folks in 2.5 years. And so I actually, since this COVID
Wow.
pandemic
It's a
started,
long
I
time,
hadn't
Jen.
really seen my dad. And he is now 87. So it's sort of a poignant time of life, right?
Yeah, I would say.
Gotta, yeah. And we had great conversations, kind of free association going all over the universe. It was great. We had a great time.
I'm really glad you did. I am
Yeah.
very, very happy. I'm just doing a little setting, but so I had seen my parents in August, and it was also a long time. So we both got to see our parents, which is super important at this time,
It is.
like we were talking about before. And I'm so happy that you did. It makes me really happy. All right.
Well, shall we give the 30,000-foot overview of where we're
Yes,
going
we
tonight?
should, Jennifer. Take it
It's
away.
it's
Take it
going to
away.
be the Arctic and the Antarctic, just to kind of cut to the chase.
Yeah.
But not just.
Mm.
So the first one, we're going to kick it off with a bang. From the Times of Israel is the
Mm-hmm.
publication. Headed for a sixth mass extinction, MIT geophysicist warns oceans are on the brink.
Oh, boy.
Yeah. And then our next one is from, I think it's a Russian publication because it's arctic.ru, which would be a Russia
Mm-hmm.
URL. About 140 permafrost thaw monitoring points to appear in the Arctic by 2025. So it's
That'll be
what's
a good one.
happening to the
Mm-hmm.
permafrost.
Yeah.
Uh,
Permafrost night.
and
Yes.
yeah, and I think you have some pictures to show from Twitter. Are you going to show some of
Mm-hmm.
those?
Oh, yeah.
Yeah,
Mm-hmm.
permafrost stuff.
Yep.
And something about the cat is a psychopath. Do you want me to include that in it? Or
Oh
we'll
gosh.
just kind of launch that one on
Yeah,
them. We
we'll do
won't say
that
what
one.
it is. It'll be a
That's
surprise.
yeah,
Then
that
we have a
breaks up the night.
surprise about psychotic cats. The- then
Oh
we
my
have one
god.
from phys.org. Fire hastens permafrost collapse in
Mm-hmm.
Arctic Alaska. Study finds. What a freaking shock.
Yeah.
Um, and all this melting or, thawing of the permafrost and melting of Arctic sea ice, basically heat, heat, heat. New source of potent greenhouse gas emissions identified in
Mm.
permafrost. This will not come as a shock to any of
Mm-mm.
you. No.
No. None of
And
you.
then none of you.
Mm-mm.
Certainly not. Then we have one from SciTech Daily. Rainfall in Arctic will soon be more common than snowfall, decades earlier than thought. Yet again,
Yeah.
keeping with our theme of everything more than expected. And then we're going to end up with this one, which I think is really, really interesting. It's from the Weather Network, and it's about Antarctica, and in
Mm-hmm.
particular, the Antarctic, um, what is it called? The Antarctic circumpolar current. So we're going to learn about
Yeah.
the Antarctic
Yeah.
circumpolar current and what it's up to and
Okay.
why. And it
We're bringing
says
up the rear.
one of the strongest ocean currents is speeding up, concerning scientists. You betcha, baby.
All
So,
right.
Sandy, that is it.
All right.
That
Well,
is where
I
we're
think
going.
what we're going to do is start, and I'm going to get us all ready here. And
Mhm.
if you give me a second, we'll pull up the articles and we will take you on a trip, and we will put ourselves in here. Right there. All right. So let's go for it. Do you want to head off with this one or you want
You
me?
you go ahead. You go
All
ahead,
right.
and then whenever you want, you can hand it over if you feel like it.
All right, my friends, we're going to start with this one because it caught our eye. And it caught our eye and Earth's skin already bears the scars of the climate crisis. Fires they ravage forests, hurricanes swamp coastlines, floods drown city blocks, and entire species disappear. But beneath the surface layer, in the planet's rocks lies evidence of past catastrophes much more severe. Daniel Rothman, who is a professor of geophysics at MIT, believes we may be creeping towards a calamity for Earth's life systems as a whole. You think? The planet's sixth mass extinction event. The staggering amount of carbon humans are pumping into the atmosphere and the oceans may soon cross a threshold that will disorder the planet's carbon cycle and cause a cascade of disruptions we cannot fully envision, Rothman said. What we do know is that such disruptions in the past have coincided with a series of mass extinctions in the 540 million years since life became abundant on the planet. And when the climate crisis is usually framed in terms of years, right? Decades or the next century, mass extinctions play out over thousands of years. Every time there has been a major event in the history of life, there has also been a major perturbation of the environment. These things tend to come together, he said. These disruptions are associated with the carbon cycle or the exchange of carbon in the environment. And we know that by traces that are left in the carbon chemistry of old rocks. Now, the average person doesn't really think about such long timescales. Of course they don't. But that's also geology's gift to the world, Rothman said. Wow. Look at that. That's New Delhi. Look at the smog
It's
there in New
really
Delhi.
awful.
Yeah, well,
I
they
mean,
have to.
that's like
It's horrible.
8 or 10 in the morning or something, and look at that. You can't even see through it. Nothing's just
No,
black.
it's yuck.
Horrible.
So
Very
testing the water, it is. It's a sad way that we're disgusting. All right. I'm not editorializing. So there have been many disruptions of the carbon cycle in the past that were significant for the climate, but did not result in mass extinctions. However, Rothman from MIT's Department of Earth, Atmospheric and Planetary Sciences, just in case they forgot to tell you before, investigated what made the difference, or put another way, why were mass extinctions special? Well, carbon is a crucial element in biological compounds and a major compound in many minerals. It enters the atmosphere as carbon dioxide when we burn fuel. The carbon cycle is a complex, nonlinear system, right? And it centers on a loop between photosynthesis and respiration. As part of the cycle, the element is exchanged between the atmosphere and the upper levels of the ocean. So too much carbon can outpace the ocean's damping mechanisms and overwhelm the cycle, leading to a cascade of positive feedback that disrupts the entire system. That perturbation can take thousands of years to even out. So too much carbon in the ocean renders it more acidic and inhospitable to many types of life. 4 of the 5 past mass extinction events appear to be associated with an increased rate of carbon cycle change, and it looks as if there's a special rate of change which is acting as a threshold. Rothman concluded that on a scale of about 10,000 years, what matters is the rate at which carbon is added to the atmosphere. So on a short time scale, a century or two, what matters is the sheer amount of carbon being injected into the skies. Oh, God. Like the video, just spewing out. An analogy: if water flows out of the bathtub faucet faster than it goes down the drain, eventually the room will flood. Now imagine you open a fire hose in the bathtub just for a few seconds. Almost no water goes down the drain, and it may cause a flood. So what matters is the amount of water you pour in during that short interval. We are adding carbon to the atmosphere much faster than past geological events on a shorter time scale. Rothman calculated that the critical threshold for carbon in the ocean is around 300 gigatons in a century, and we are on track to add up to 500 gigatons by 2100. He published peer-reviewed papers on the subject in 2017 and 2019. And oh my goodness, I think the Times of Israel is just pulling pictures. 2 million. Oh, I see. It goes this way. 2 billion years of magma. They had it. Okay. Most mass extinctions do not come about with an asteroid impact and a burst of light, but they take place over eons. To the best of our knowledge, the planet's most severe mass extinction event, right? The Permian extinction took place around 252 million years ago, Jennifer. It coincided with massive volcanism in the Siberian traps, a vast region that burst with eruptions and spewed magma for some 2 million years, and that's why they have this. Pumping chemicals, including carbon dioxide, into the atmosphere. So some 3 million square miles of basaltic rock carpeted today's Russia as a result. The volcanic event, one of the largest known, is believed to have spiked ocean temperatures and increased the acidification, triggering a collapse in global ecosystems. So the Permian extinction killed off over 96% of marine species and over 70% of terrestrial species, according to the 2018 MIT report. Jennifer, we went over that. I remember we did. We did.
Yeah, we did.
Yes, we did. So it began abruptly, and it took place over as much as 60,000 years, researchers said. a blink of an eye in geologic time. And I really like that term, the blink of an eye, because we are living and we think that, we're living and we're saying, oh, things that have happened in the last 50 years. That's that's the fastest blink of an eye ever compared to 60,000 years, right? Like
Yeah.
fast. We've done it in 50 years. We fucked everything up in 50 years, Jennifer. 50 years,
Yeah.
pretty much. I mean,
That's right.
the industrial,
Yeah.
it started how long ago? But so the KT extinction event that wiped out the dinosaurs and 3/4 of plant and animal life on Earth 66 million years ago was the Earth's most recent mass extinction event. It was likely tied to an asteroid impact, but also coincided with tens of thousands of years of massive volcanism in the Deccan Traps in today's India. And guys, look at this picture for 1 second. I have to do something. Okay, hang on. All right, I'm coming back. Oh, geez. No, I'm sorry. I forgot to turn the fan off. And I have a fan on, and it will interfere with the sound. And I totally forgot to turn it off because my laptop overheats, guys. And so I have to turn this stupid big fan on. All right, let's finish. Now that I did the little live stream snafu of the evening, tipping points. So the deep past is murky, and the records are incomplete, and little is known with absolute certainty. Moreover, extinctions take place on a continuum, with species dying out even when systems are stable. Paleontologists, scientists who study the history of Earth, they distinguish between kill mechanisms and other factors in extinction. So, for example, carbon dioxide in the atmosphere may not have killed species directly, but it may have triggered the ocean acidification, which could in turn have annihilated the marine species. Isn't this just so uplifting? Rothman said that during the times of environmental stress, we have a record of carbon cycle behavior, and there is a clear association between that carbon cycle change and mass extinction, but many other factors play a part. So he compares the mass extinctions, now this is really interesting, to the 2008 financial crash. You can blame mortgages, but it is a whole set of things. Once there's a modest instigation, the whole thing goes crazy and basically becomes unstable, right? But Jennifer, listen, people can really relate to that. Everything's about money. So actually, he's pretty brilliant. He says once there's a modest instigation, the whole thing goes crazy and it basically becomes unstable, and you have this recession. Right? So it's catastrophic change, he said. To point your finger at any one thing, you might have been able to identify some kind of proximate cause. But identifying what the real cause is, which is the way things interact with each other, it's like a different game. So there are what we call tipping points, which we all know about ad nauseum, or positive feedbacks in the system, and we don't really understand them. He said, this is really at the vanguard of scientific research in this area. So, for example, many marine animals form the shells and skeletons using carbon and are coated with algae made with organic carbon. When they die, the shells weigh the organisms down and bring the bodies to the seafloor, where they are buried by sediments, sequestering the element and removing it from the upper ocean. Ocean acidification impedes those organisms from forming shells, further driving up the amount of carbon in the upper ocean. This article actually goes over everything we've talked about for the last 3 years.
It's a huge summary. It's a retrospective.
I kind of really like starting out this way. It's kind of, I read it, but I didn't realize reading it out loud, it would give me the impact. These kinds of positive feedbacks are important, partly because we don't understand them, and we should understand them, and partly because the magnitude of the cost associated with them is so large that it points out that ignorance is not a good thing. Oh my God, we are living in the time of ignorance, aren't we? Don't you think? We live in the clueless moron world. Oh. So it's a global effort. He says he does not study the fossils or carries out the digs, but he does the calculations based on other research. The most clear fossil record is in China. Wow. Researchers there can date extinctions in the fossil record and match those dates with evidence of massive volcanism and the carbon chemistry of rocks in other areas. Mass extinctions leave both a marine record and a terrestrial record, but he and other researchers focus on the marine record because the data is clearer. The marine geochemical records and sedimentary rocks and the fossil record are more straightforward to interpret. So a fossil fuel found on land might be indicative of a specific environment, but the oceans are well mixed, and a find is more likely to be indicative of the global environment. This is so cool. Look at that one. That's a big dig. There is a debate over whether we have entered a mass extinction event caused by us, the Holocene extinction. The rate of die-offs is already far higher than the natural extinction rate. Oh, this week there was a big one that came out about 2021 extinctions, Jen, but we can't do it tonight. So he said the current research, which involves counting fossils and current die-offs, is factual and connected to his researches, but it's outside of his realm. And he says many of the current extinctions are due to land use. And it's hard for him to conclusively say that we have crossed the Rubicon into a mass extinction grade event. So he began his research into the area 5 or 6 years ago, partially to address this question. He said mass extinctions, they represent some type of cascade of positive feedbacks that cause a global ecosystem crash. So what we're seeing today is very serious. However, I don't know how much is necessary to move us to the tipping point that would create that global catastrophe for the global ecosystem, he said. I can't say we haven't. I just don't know how to say when we would. So the scientific endeavor, some species have gone extinct because of human greed and cruelty, others by negligence. Some die off despite our best efforts. And the vast majority disappear before we even know their existence. We still don't understand the ramifications of extinctions or the destruction we wreak on the environment. The effort to understand climate change, extinctions, and what causes them is part of a continuing scientific effort to understand how our world came to be, what happened on the way to the present point. A large number of people around the world are trying to figure out the history of the environment and the history of life and what it might mean. The endeavor will help us to understand the dangers of modern climate change. So events like COP26, climate conference are a step in the right direction, but reaching political agreements and getting people to cooperate, it's still far outside our grasp. You think? It's,
No kidding.
I wonder what could I play for that one? I could do that. Yep, you think? It is. I think, frankly, a more difficult problem that, well, we talk about methane all the time, don't we? Than the sort of stuff I work on, because I'm just trying to figure out what the truth is, Rothman said. One would like to see more, but good people are doing their best. Rothman co-founded MIT's Lawrence Center, a curiosity-driven advanced climate research center to better predict and understand the most complex scientific challenge we face as a species. So we need to limit the ways we pollute the environment, and we need to find ways of diminishing the amount of CO2 we put in the atmosphere. Of course, we already knew that, but this provides another kind of reason to do it, he said. There are things that could happen which essentially go beyond our ability to understand them. Wow, that was really good. And I'm going to give him an applause for that. That was really great. Thank you so much, Dr. Rothman. All right. Holy shit. What a
That
way
was a
to
tour de
start.
force.
It sure was.
Yeah.
What a way to start. I really liked it. Woo! Okay. Well, listen, Oh Hunter says subscribe, share, and most importantly, like for the sound effects. Oh, yeah. Oh, yeah. All right, Jen, well, you're going to take off on the Arctic now. It's your
Okay.
turn because this is your especially a special, your specialty. So take it away, sweetheart. It's
All
for
right.
you.
All right. About 140 permafrost thaw monitoring points to appear in the Arctic by 2025. Everybody is watching the permafrost with bated breath and trepidation, probably. That's my comment, not what it says here. Over 40% of buildings and structures in the Arctic bear signs of deformation due to the permafrost thaw in the cryolithic zone. There are plans to construct 140 monitoring points by 2025 to track changes in the permafrost. Permafrost degradation causes substantial loss in hydrocarbon production. Oh, tant pis, so sorry. Technical accidents and road pavement damage. At Federation Council meetings on the Clean Arctic Public Federal Project, the official underscored that the permafrost thaw remained a pressing problem that affects the economic development in the Arctic. So this in this meeting, the participants that his ministry and the other parties concerned developed and submitted to the government a plan for creating a government system to monitor the permafrost condition based on the observation network of the Federal Services of Hydrometeorology and Environmental Monitoring. About 140 monitoring points will be established by 2025. This will dramatically reduce, in some cases, eliminate the risk. I do not think it will eliminate the risk arising from the development of Arctic cryolithic zone in the medium and long-term perspective. In addition, the construction of the North Pole ice-resistant self-propelled platform, a unique research vessel outfitted with state-of-the-art equipment, is nearing completion. This is from a Russia publication. So everything they're referring to is happening in Russia. According to the deputy minister, it opens up new opportunities for exploring hard to access regions of the Arctic and then drill the hell out of them, I would imagine. So that is from a Russia publication. They're watching the permafrost because it seems to be thawing rather quickly. Yes, Sandy? Sandy?
There's more structures in the Russian Arctic right there.
Yeah.
Look at that. That was you just go to Twitter and you do a little thing on permafrost, and a lot of stuff does come up, and you can, I mean, that's all you have to do, and then you find, look at this guy, a foal from the ice age perfectly preserved in the Siberian permafrost. So it's like kind of like Siberia Arctic, Arctic night. And I think we're going to go through this article. So should we move do you want to move to the kitty cats and make a joke? I got to show you guys this. And then Jennifer's going to take up the rest of the Arctic. Let me tell you, this was hilarious. On Twitter, it was a big thing, evidently. People were like, oh my God, scientists developed a questionnaire to identify whether your cat is a psychopath. Holy crap. Well, let me tell you, Jennifer, I mean, like, does anybody care out there? What is your cat thinking? I have 7. I am not going to take the time to do a survey online about cats. But what do you think out there, guys? Should we what do you think? Did the cats get this? Did they get the toilet flush of the day? The cat research? What do you think? All right. So anybody that wants to find out if your cat is a psychopath, the link will be in the show notes. Okay. Now we're going to move on. Yes, everybody's like that. This is nuts. Hi, Kay. Yes. Hi, Katie. Yeah. Okay. So let's move on. And Jennifer,
Yeah.
take it away.
Shall I? All right.
Yes, ma'am.
So this is an article that just came out yesterday in phys.org, and it's also about the permafrost. You can see there's a theme here.
Yes, there is.
Uh, Fire hastens permafrost collapse in Arctic Alaska, study finds. So, while climate change is the primary driver of permafrost degradation in Arctic Alaska, a new analysis of 70 years of data reveals that tundra fires are accelerating that decline, contributing to
Mm-hmm.
contributing disproportionately to a phenomenon known as thermokarst, the abrupt collapse of ice-rich permafrost as a result of thawing. Reported in the journal One Earth, the study is the first to calculate the role of fire on the permafrost or on permafrost integrity over so many decades, the researchers said. The Arctic permafrost is a vast storehouse of frozen plant and animal matter, a carbon stockpile that, if thawed and degraded, happening on a planet near you, could more than double the amount of
Thanks, Jen.
carbon. Yes, in the atmosphere.
Ooh.
So get this. I mean, we kind of made a joke right in the middle of it, but it could double the amount of carbon in the atmosphere,
Oh my
period.
God.
Double
Wow.
it.
Wow.
That's the permafrost. That's the danger of the permafrost. This
Scary.
process, because it's very unpredictable, is poorly understood.
Mm.
Um, with this study, we're advancing our understanding of the permafrost ecosystem. The team analyzed 7 decades of air and satellite imagery to calculate the rate of thermokarst formation in different regions of Arctic Alaska. Researchers also used model machine learning based modeling to determine the relative contributions of climate change, fire disturbance, and landscape features to observe permafrost
Bus
declines.
declines. Mm.
Yeah. So they've got a whole machine learning model around it. We found that thermokarst formation has accelerated by 60% since the 1950s. That's just 70 years. Jesus.
Wow. Wow.
Yeah.
My favorite
Although
word.
climate, yeah, no kidding, right? Although climate change is the main driver of thermokarst acceleration, fire played disproportionately large role in that process. Fire burned only 3% of the Arctic landscape in that time period, but was responsible for more than 10% of thermokarst formation. Repeated fires in the same areas continued to damage the tundra, but did not further accelerate thermokarst formation. The study revealed that a single fire could accelerate thermokarst formation for several decades.
Dang.
Models predict that thermokarst will only increase with climate change. In addition to thawing permafrost, climate warming dries out the tundra, increasing its flammability. As we've seen, Sandy, we've been showing all those zombie fires in the permafrost and all
Yep.
that stuff. This makes it more than likely that lightning strikes will spark fires. Yeah, especially if it's peat, causing even more permafrost degradation. Thawing and collapsing permafrost also leads to other landscape changes. For example, lakes sitting on frozen permafrost depressions may drain gradually or suddenly when that permafrost degrades.
Mm.
The loss
Mm.
of
Mm.
permafrost can open up the floodgates of environmental change. And this paper was entitled Thermokarst Acceleration in Arctic Tundra Driven by Climate Change and Fire Disturbance. So
Okay.
there you go. That's what can happen. with your permafrost.
Yeah. Well, how long have we been talking about permafrost and nothing gets better? And I have to
No.
say to you guys out there in the audience, I understand that it's stressful and disturbing and upsetting to read about these things, but we are probably, there's not a lot of people that go over all this that you can come to and hear it. And yeah, we're here. We have to support each other. But would you rather not know and just go on and be a clueless moron? Or would you rather know and understand and live your life to the fullest and do and I'm not like the last article. I'm not saying don't do anything. Be active. Get involved in things and understand. That's all. Because I'm looking at the chat and I don't want everybody to just be so upset over this stuff. There's proactive things you can do in your community. That's what it is. Okay, Jen, I did my little, I am a social scientist, as we all well know. All right. Take it away.
Oh, me again.
Oh,
All
yeah.
right.
You're the permafrost girl. This is your area.
Oh,
You're the expert.
okay. All
Yes.
righty then. So this is a publication that just came out 2 days ago, hot off
Mm-hmm.
the press from newatlas.com. New source of potent greenhouse gas emissions identified in the permafrost. Oh,
Oh, boy.
dodo. Yeah, so this is all about nitrous oxide and how
Mm-hmm.
it's increasing, just to give you a frame of reference. It may not be the headline star of climate change discussion, but nitrous oxide, N2O, is still a potent greenhouse gas. And now it looks that we may have underestimated how much is being released. A new study has identified the thawing Siberian permafrost as a huge, previously unknown source of N2O. Carbon dioxide, the primary greenhouse gas of concern, followed by methane and then nitrous oxide. But don't discount the bronze medalists there. What N2O lacks in concentration, it more than makes up for in potency. Pound for pound, nitrous oxide is 298 times stronger warming
Wow.
agent than carbon dioxide. That's 300 times stronger molecule for
Whoops.
molecule. A
What
little
they
bit
do
of
here?
nitrous oxide can go a long way.
Oh, I see.
And an additional benefit, it can degrade the ozone layer too. Worse, worse still, it's saving
Oh my
grace.
God. Hang on. Go ahead. You read. I don't
What
know
is
what
going
happened to the
on?
stupid. I don't know. It's giving me an
Okay,
ad. It is advertising epidemic sound. I
don't
don't,
worry.
which I really don't know why
I
I
will
can't go
read.
back.
You
You
figure it
read.
out.
Mm-hmm.
All right. Worse still, it's saving grace that at least there isn't as much of it up there in the Arctic may not hold true for long either. A recent report found that we may be underestimating the N2O emissions from agriculture, where it is produced as a byproduct of nitrogen rich fertilizers. Oceans also emit a decent chunk that's growing as human activity makes the waters more acidic. So basically, the ocean is burping nitrous oxide. Gross
Mm,
and dangerous.
mm,
And
mm,
now the
mm.
Siberian permafrost can be added to the list of increasing sources. New research, led by scientists at the University of Eastern Finland, have found
Finland.
that nitrous oxide emissions from a type of permafrost known as Yodoma are growing faster than expected. Yodoma
No.
permafrost contains a huge amount of organic material and covers more than 1 million square kilometers, which is approximately 300, more than 386,000 square miles, just for
Wow.
reference, across Siberia, Alaska, and Canada. Previously, it was assumed that the nitrogen cycle in those cold soils was a slow process that wouldn't result in significant nitrous oxide emissions. But for the new study, team measured those emissions at different points along the Lena and Kolyma rivers in eastern Siberia. The team found that the most recently thawed Yudoma permafrost
Mm-hmm.
did start off producing nitrous oxide emissions, but within a few years, those emissions accelerated drastically. Oh my God. So it starts off slow, gets stronger. Eventually, they were found to be emitting between 10 and 100 times more nitrous oxide than normally expected from other permafrost soils.
Oh,
Oh
that's
my
nice.
God. Oh my God,
Nah,
Sandy.
it's scary. A little
Oh
bit.
my
I
God.
know. I know. I know, Jen.
On closer inspection, the researchers uncovered the mechanism behind this increase. As sediments dry out and stabilize after thawing, the microbial communities living in them change. The
Mm.
population of microbes that produce nitrous oxide precursors grows, while those that consume the gas shrinks. So they become nitrous oxide producers, it looks like. Further study will be needed to assess the extent of these emissions and incorporate their impact into climate models.
Mm-hmm.
Oh my God.
Study,
That is
study.
so bad.
That's what
Yeah.
that's what's gonna happen. Study, study, study. Learn, learn, learn. I mean, what I don't know what you know what the end of it is. What we just go and understand. I guess the quest for knowledge, Jennifer, is something so
Yeah.
super important. At least to you and I know it is to everybody in our
For
chat.
everybody who's here, anybody who bothers to
Everybody
listen
who's
to
here.
this channel, they get the bug.
Yeah. And even when
They
you're
get
not
the
with me,
bug.
and I veer off into all these different kinds of these places. It's still, we still are giving you who is talking about Siberia. We are, and we would love to be able to go, but I don't know if I'm ever going to fly again. I don't know. We don't know, but everybody's pretty busy in the chat, so I guess we should move on and
Yes.
do the rainfall in the Arctic. Now we're talking about the rain. So I guess I could start this one because you're gonna finish us up with the ocean. So
Yes.
rain
You go
in the
ahead and read
Arctic.
this
Alrighty. So here we are. This was December 5th. Rain in the Arctic will soon be more common than snowfall, decades earlier than thought. All right. I don't. I like the graphic. That's the 2 layers of ice and deep snow following the rain on snow events of November 2006. So it's been going on for a
You
little
can
bit of
see
time
them.
there. Yeah. And
You
that's
can
old. I
see
mean, it's
like the
going
dark
on.
lines, each layer. You can see those dark lines
That's what,
between the
14 years ago?
seasons.
Jeez.
I don't know.
Yeah, it's 2006 that picture was from. So changes will happen decades earlier than previous thought. More rain than snow will fall in the Arctic, and this transition will occur decades earlier than previously predicted. A new study by the University of Manitoba and co-authored by scientists at the National Snow and Ice Data Center at Boulder. Yay! Yay for
Yay,
Boulder!
Boulder!
Yay for
See?
Boulder! That's
Yay,
Jennifer.
Boulder!
Yep.
See,
Uh-huh. That's
Boulder
that's
again.
Jennifer. I'm proud of that school. Your school is
Oh yeah,
amazing. Uh
yeah.
More rain than snow. Oh, blah, blah. Okay, projections from the latest models published by an international team of researchers led by the in the journal Nature Communications show a steep increase in the rate and range of precipitation expected to fall in the Arctic, and that most of these future events will be rain. This shift is occurring due to rapid warming, sea ice loss, and polar heat transport in the Arctic. There are huge ramifications of these changes, which we note in the paper, such as a reduction of snow cover, increased permafrost melt, more rain on snow events, and greater flooding events from increased river discharge, all of which have implications on wildlife population and human livelihood, says the lead researcher, Michelle McChrystal, who is a postdoc fellow at UM's Center for Earth Observation Scientists in the Clayton H. Riddell Faculty of Environment, Earth, and Resources. The transition to a rain-dominated era in the Arctic is forecasted to commence at different times. I'm going to move us over. I'm playing a little bit here. Do you mind if I play? I'm just trying to see.
Mm-mm.
I'm playing for a second, guys, because I have the toys here. Okay. We now know that in autumn, these new models predict a shift to occur between 2050 and 2080, so right in time for our children and grandchildren, or those of us that have grandchildren, whereas the old models predicted this to occur between 2070 to 2090. And what could be considered a harbinger, as these researchers were prepared in their report in August of this year, rain fell for the first time in recorded history on the highest point of the Greenland ice sheet. And I think we talked about it, but a lot of people were covering that one, Jennifer, because of course that was big news. The fact that we're getting rainfall on the summit of Greenland right now, and that we're maybe going to get more rainfall in the future, it kind of staggers me, McChrystal says. And when we talk about this happening, in 2100, it seems like such a long time away, but it's only 80 years. That's the next generation. And if we continue the trajectory that we're going, a lot of issues might happen faster than what we've projected. The paper, new climate models reveal faster and larger increases in Arctic precipitation than previously projected, warns that reduced snow cover will further exacerbate Arctic and global warming through the albedo feedbacks, increased winter carbon dioxide fluxes, methane releases from soil, and thawing permafrost, the recurrent theme of the night. The precipitation change will also affect soil moisture and groundwater and the underground fungal networks that support all the above ground flora. And more rain than snow events can be devastating to wild caribou, reindeer, and musk oxen populations. The rain may freeze and create layers of ice, inhibiting them from accessing forage buried under snow. But migratory bird populations in the Arctic are expected they can do well with these warmer and wetter conditions. So, Jennifer, it might be a bird's world. Maybe it'll be a bird's world, Maybe it's the birds.
Maybe.
We're learning, right? We're learning along with the scientists. The research team, which includes the members from the University College London, CU Boulder, University of Lapland, and the University of Exeter, note if we can remain under 1.5 degrees Celsius of global warming, then some of these projected changes, namely the transition to a rainfall-dominated precip, may not occur in some regions of the Arctic. But if we continue on the current trajectory, which given current global policies mean we could reach 3°C Celsius global warming by the end of the century, that this transition is going to occur. So the new models, they couldn't be clearer. Unless global warming is stopped, the future Arctic will be wetter. Once frozen seas will be open water, rain will replace snow, says co-author James Screen of the Department of Mathematics and Global Systems Institute at the University of Exeter. With what this precipitation transition means for sea ice, the dominating landscape feature of the Arctic is unknown. Now, in short, more rain means more fresh water at the ocean surface, which might aid sea ice growth, but more rainfall is associated with what? More heat, which would see ice degrowth. Ice growth would decrease sea ice growth. So people might say, well, what does that have to do with me? Right? Like everything. Well, this is going to affect you. And in actual fact, it's affecting you now, McChrystal says. Let's get her, Jennifer. For
Mhm.
me, I think what people need to understand is we live in a global society where everything is interconnected, and that's true of the climate. We have a global climate. So, what happens in one region will affect what happens everywhere else.
Indeed.
Wow. This was pretty good.
Indeed.
Pretty good article. I'm glad that we did this one. I am.
Yeah.
It just, it really encapsulates the theme of the night. And we have people just don't think about it. Nobody thinks about this, especially in the United States on a daily basis. And nobody thinks of what's coming up next. And Jennifer, she's
Mhm.
going to take up the rest of the story.
Yeah. Indeed, indeed. So we're going to
Indeed.
go down to the South Pole, Antarctica, and we're going to
Mm-hmm.
talk about currents. And as we talk about this, just keep in mind there's a similarity to what's happening with the jet stream, because as you all know here, the jet stream is getting wavier and slower, and that is due to the decreasing delta between the North Pole and the more temperate regions. And as that amount of temperature between them gets smaller, that vortex starts to collapse. And that's what we're seeing with the degradation of the jet stream. So air is a fluid, right? It's a
Mm-hmm.
fluid that's less dense
Yeah, Jen.
than water, but it's a fluid. And so this a different type of phenomena is happening in Antarctica. And the you think of like the Antarctic current is like the jet stream, it's just a more dense fluid. But there, the delta between the cold, because there's so much cold being injected into the seas there from all the thawing of the Antarctic sheets of ice, right?
Mm-hmm.
But the ocean around it is getting hotter and hotter. So in Antarctica, we have the inverse situation where
Wow.
the delta
The
is
inverse.
increasing. It is increasing. So that means the temperature difference between the cold, cold water of Antarctica directly and the warm Southern Ocean that's encroaching on it, that delta is increasing. Hence, this polar circumnavigation or whatever it is in Antarctica
Mm,
is getting stronger
mm,
and more
mm.
fierce. See,
Wow.
it's just the inverse situation. So I
The
found
inverse
this.
situation.
It's the inverse situation, but it's the same principle. They're both fluids, but different things are happening to them, you know. So one of the strongest ocean currents is speeding up, concerning scientists. Although the Southern Ocean is a remote part of the planet, scientists say that the warming occurring in this region could have impacts on the global climate. Decades of data have revealed that the Antarctic Circumpolar Current, also known as the ACC, the only ocean current that encircles the entire globe, has started flowing faster. The ACC wraps around Antarctica and is a barrier between the tepid subtropical waters north of it and the cool waters to the south, helping keep temperatures low near the frozen continent. The subtropical waters above the ACC have absorbed significant amounts of heat over the past few decades. In fact, over 90% of the excess heat in the atmosphere created by greenhouse gases has been absorbed and stored in the oceans since the 1970s.
Hmm.
The Southern Ocean, which is where part of the ACC flows through, has absorbed particularly high amounts of this extra atmospheric heat. Scientists have noticed that the additional heat is increasing the temperature difference. That's what we just talked about
Right.
between the two areas of water in the currents that the current separates, which is causing it to flow at a faster rate. So, the study published in Nature Climate Change used satellites and Argo, which is a network of floating robotic instruments that records the ocean conditions
Wow.
like temperature and salinity. There are currently 4,000 floats scattered across the world's oceans that are collecting data. Warming global temperatures have also been affecting prevailing westerly winds and causing them to energize ocean eddies, which are smaller circular currents of water near the ACC. However, these winds are playing less a role in the ACC's flow rate than scientists initially suspected. The ACC is mostly driven by wind, but we show that changes in its speed are surprisingly mostly due to changes in the heat gradient. See, guys, this is exactly what we were talking about. Same, same.
Mm. Mm-mm-mm.
Yeah. From both observations and models, we find that the ocean heat change is causing the significant ocean acceleration detected during recent decades. Between 2003 and 2019, Antarctica's ice sheet lost an average of 118 gigatons of ice each year. Oh,
Holy crap. That's
and
a
and
lot.
that number is going to go up,
Gigatons.
making
Oh
this
boy.
continent one of the fastest changing landscapes on Earth. Warming ocean temperatures exacerbate the melting that the ice sheets are experiencing because they thaw the base of glaciers and enhance their breakage. Global impacts are also possible if this region continues to warm abnormally fast.
Oh,
Wow, what do you
okay.
think the
Yeah.
chances of that are?
Yeah, exactly. Oh my
Since
God.
all ocean currents act as a conveyor belt that circulates heat, nutrients, and carbon around the planet. So I thought that was just amazing because it really shows the principles of circulating fluid and the effect of temperature deltas and how it affects that circulation,
Wow.
either whether it be water or air. The principle is the same.
The principle's the same. That's interesting. Just
Yeah.
tonight I've learned quite a bit, and the chat seems to be pretty hip. I'd like to take questions. If anybody has questions or if anybody wants a comment up, I certainly will. Kim is saying, give us a like. Give us a like. Give us a like. Torstein from Greenland. Torstein Fidel going south joined us. He's in the
It's 10
chat.
o'clock.
And Boyd says, wait. That's they're going fast. Virtual eco apocalypse pals. Howdy. Oh boy, eco
Hi,
apocalypse. Well,
Void.
what are you gonna do?
I love
I
I
mean,
love Void. He is so
yes.
smart. I read
Have you
his comments and I'm like, "Oh my god, he's so smart."
have you ever gone to his channel and meditated? I have. He's
No.
his channel is wild. His meditations. Let's see, Jin P. Stopping or changing the rate is 1 million times more energy demanding than stopping a tractor trailer rolling downhill. Now Jennifer, I don't know, have I forwarded you the information on physics it's just we're gonna have to do a whole show on his
Mm.
material, and I don't know if he will come on with us, but some fascinating information, and I can't even go up. So, Christopher, what are you asking? What's with all the weather whiplash events? What's with it? We've just been explaining it for the
What's
last
with it?
hour.
It's happening, it's accelerating, it's happening more and more. It's flooding, it's droughting, it's sliding, it's, bubbling. The whole thing is, going down before your eyes. That's what's
It is.
happening. And it's
It is.
accelerating. It's good to keep in mind the meaning of acceleration and exponentiation, right? I mean, we all know it, but it's so counterintuitive that we have to remember that we are on an exponential slide in this breakdown of the biosphere. I mean,
And
this
we
is what's happening. It happens not very often in the life of a planet. We just happen to be witnessing it. And it's happening so, so quickly, faster than any other extinction event has ever happened on this earth thus far. And there's so much momentum in it that he's absolutely right. The momentum builds up, and I mean, you can't stop it very easily, as we have seen.
Oh, wow. Hey, we have somebody new. Congress for Idaho Law left you a note and messenger to talk. Okay, interesting. New person. Thank you for joining. I hope it's all good. Yeah, we do. And thanks, people. I got boosted at Walmart yesterday. Haha. Okay. A topic we never talk about here because everybody's got a different thought. Bob, hi, Bob. Where are my children? It's 10 o'clock. Oh, you heard? I never turned off the system audio, so when it says 10 o'clock, it tells me that. Well, we've done an hour show. Thank you for joining us. Yes, Mira Shah. She thank you. She's on Facebook, and I didn't even do anything on Facebook today, but uh
Somebody wants to
give us
say
the NASA.
hello.
Oh, there's your kitty.
Hello, hello. There
Yay.
she is. Hello,
Aw.
say hello.
Hello, hello, hello. We have the little meow, right? Well, everybody, thank you so very much for coming and liking our show, and we enjoy you. Jen, would you like to say goodnight, and I will then put it
Well, I mean,
away.
it's been an incredible show, and you can see how everything is getting hotter and thawing and melting. And, in Antarctica, I thought that article was so amazing about
Yeah.
the ocean current in
Oh.
Antarctica speeding up and why it is. So we're learning scientific principles as we watch this place melt down.
Yeah, but we're here, and we have to make the best world possible. We have to for everybody's kids and grandkids and pets and animals and wildlife and amoebas and all the stuff in the oceans, and there you go. All right, guys. Jennifer and I will see you next Friday. I will be on Monday and Monday night, and we are going to do a State of the Planet next week with Nicholas Humphrey, Antonio Reed, Jennifer, and myself. We're trying to get it all together. So look forward to that. Nicholas will fill us in on his PhD work, and there's a lot going on with Antonio, and there we go. What do you think?
Yeah, well, I think, we did a pretty good job of summing up the situation this week, and I'm looking forward to continuing our adventure as
All
the
right.
biosphere dissolves.
Peace out, guys.